Well, good morning, everybody, and welcome to this IoT session organized by the OSGi. I hope you all enjoyed the keynote speech this morning and learned a little bit more about OSGi. My name is Jules Armand with Huawei, and I'm representing the company, the OSGi Board of Directors, and I'll be moderating this session until lunch. Just a few points. The draft specs in release 7 is right there, the link is there. There's a lot of new features. You might have heard about the additional features that have been developed in release 7. There will be an OSGi award ceremony. We will be recognizing a few individuals in the company at 1:45. Please join us. And yeah, we would love to have you guys working with us, working with the OSGi community, join the organization, and work with us to develop first-class standards. And with that, I would like to hand over to Tim. Tim Ward is the CTO at Premise and a co-author of Enterprise OSGi in Action, and he's been actively working with OSGi for over 7 years. And he's the co-chair of the OSGi IoT. Tim.
So, hello everyone, and thank you for coming. I know I'm up against a number of pretty exciting talks, so thank you for choosing to be here. As Ruspa said, I'm Chief Technology Officer at Paramus, co-chair of the IoT Expert Group, which is why I'm here doing this particular talk today. And I'm going to be telling you a bit about what's going on and what it is that we do. So, firstly, we've got a lot of people here. Hopefully, you know quite a bit about OSGi, and you know OSGi is a framework that does modules, but it is also quite a lot more than that. People have been talking about OSGi and IoT, and yes, OSGi is this module framework, but it's not everything that the Alliance does. The core specification in the framework is not the be-all and end-all of OSGi. We have certification exams. There was one on Monday, which I was invigilating. I don't, do we have, yeah, we've got one of the people here. So, you know, you can do things like that. You can create new specifications and allow people to make use of features in OSGi applications that they couldn't use before. And there are 3 expert groups at the moment that do this with various domain-specific requirements. And these requirements eventually turn into the specifications that you're hearing about with the draft R7 release. So we've got OSGi, and it's more than this framework, but what makes it actually a good thing for IoT? Well, we've got in the IoT things. Now things are pretty constrained and they're probably not running Java, but they almost all have to talk to something else that's a bit more powerful than they are before they get out to the internet, and that thing's called a gateway, and most gateways do run Java, or at least some level of Java. It may not be the full profile, it may be a compact profile, but it's pretty much always there. And OSGi was originally designed to run in exactly this scenario. Residential gateways is what OSGi was originally built for. It happens to have proven to be a really good server platform, which is what a lot of people have been talking about doing with it, using OSGi to build microservices. But again, it's not all it does. And if you have this same platform at the edge and in your cloud, then the impedance mismatch just goes away. You've got the same thing on both sides, and life starts to get really interesting. Also, because it was designed to be put in residential gateways that were things that ran in people's houses and you didn't have access to, it's remotely manageable by design. You know, you can interact with a remote OSGi framework and do things to it, and that will always work because it's a fundamental tenet of OSGi stuff is designed to be remotely manageable. So that means that your edge servers are easy to update, which is a really, really good thing. Also, OSGi is dynamic. Things are dynamic. So you see sensors, you see actuators, they come and go all the time. They break, they get replaced, new ones get added. You need to be able to cope with that in the real world. And OSGi is built to do that. So it's a really easy thing to say, okay, I need to handle things being added to my system or being removed from my system and have that keep working. So this is why the dynamics are really, really important. And a well-designed OSGi system actually uses these dynamics to self-heal. So when a service when a service arrives, then the whole system will rewire to assemble to use that service. And that's why it's such a good match. When a thing arrives, you can register a service saying, "Hi, I'm a thing," and then your system will be able to take advantage of it. And later, your thing gets taken away and the service goes away, and your system reacts by no longer using it. And that's why this works so well. And it's even to the point where people talk about how resilient their systems are. They talk about in their server room, you can lose a machine and it'll cope. If people start talking about losing a rack, that's when you see people who run operation centers start to sweat. When you lose a whole rack, that's bad, because then you really are talking about, okay, maybe all the resilience we added in, how many of them were running on that rack? Losing a rack is a big catastrophe. People lose their jobs. But in IoT, losing a whole rack is entirely normal. I mean, like, really, absolutely normal. If you take off your watch, your Apple Watch, and walk off, it's gone. You've lost it. If I go into my house and I reboot my router, I experience a brief total outage for the entire Internet of Things in my house. That is a catastrophic outage. Things could just run out of battery. OSGi is designed to cope with this. OSGi can give you resilience in the face of regular and sustained catastrophic failures. And that's what you need for IoT. You can't have your IoT platform going down because there's a power cut somewhere. A power cut in one set of users' houses can't kill your whole system, because you've just got to be resilient to it. And the good thing about OSGi is when stuff comes back, because someone switches the power back on, it all just starts working again. So this is why OSGi is a good thing, and why we have an IoT expert group. So it is the newest group in the Alliance, which is why you might not be seeing quite so many things in our 7 drafts right now, and it's because the other guys have had a little bit longer than we have to get to that point. And what we're doing is we're looking at the requirements that are relevant to IoT. And that's all of IoT. It's not just smart home, it's not just industrial, it's anything that people would describe as IoT, the requirements come to us. And it's a good common ground, because you've got the enterprise expert group and you've got the residential expert group who have been doing all kinds of things, but there was this kind of gap in the middle of where stuff needed to go from one to the other, and it was never really clear where those specifications should sit. And it's because really you've got IoT, which is the middle. It's the, okay, I've got my residential or my small devices talking within a little local network here, and I've got my massive cloud over here. And IoT is about trying to work out how best to get the information from here to here. So we aren't going to just reinvent the wheel, though. We are going to be using stuff that's already there in OSGi, and the new requirements will turn into new specifications, or sometimes just updates to existing specifications. We've been finding that as we go along, there are some requirements and use cases coming in where really we are able to handle it with things that OSGi already has. It's just about knowing what stuff to mix together to make that perfect cocktail. So what is it that we actually do? I've been talking a bit about the process. What is it that the expert group is doing? So OSGi specifications, the only reason a specification exists is because someone needs it. We don't just write these things for fun. We write them because someone had a requirement. There's my requirement. So related requirements, we gather them together. And once we end up with enough things that it looks like really we need to solve this problem, because there's a bunch of related stuff that needs to work, then that gets turned into an RFP document. RFP documents are published, they're up in GitHub. Anyone can read them. You can update them if you're a member, but anyone can read them. And then when it's deemed to be ready, there's a vote. And if the RFP gets accepted, which they usually are, unless people get about halfway through the RFP, realize that they actually have gathered a bunch of requirements that match something else we already do, and then it gets closed off as actually we've already got a solution. But assuming that the RFP is still interesting, it'll get voted, approved, and it goes to the next phase, which is to turn it into an RFC document. And an RFC is where we actually get to the meat of trying to solve the problem. RFPs are all about collecting requirements. RFCs are about actually solving it. And they are discussed and debated, but once we get through the right number of iterations to come up with something that actually really works, it's not just kind of a quick fix, it's not the first thing we thought of, it's, this is the really good, simple solution to this problem, then there's another vote. In case you can't tell, we like voting. So we get a specification chapter which is based on this RFC, but the specification chapter is used to produce a reference implementation and a compliance test suite. And you always have all of those things, and ideally they're produced by different people. And there's an important reason for that, which is that the specification can only be complete once all of these three things are ready. And if you've got independent people doing it, you've got verification that each bit actually makes sense on its own and based on the information from the other two. Then we have another vote, because as I say, we like voting. So once we've got a new chapter ready, which is what this specification thing turns into, a chapter in the book, then you eventually get a release of the next specification. So we've got the draft release of R7 for the core and compendium, which is publicly available now. Typically these releases happen every 18 to 24 months. So that's the kind of release cycle that you're looking at. It may seem like this is overly complicated, but we found that it's really necessary to make sure that our specs are good quality. And one of the things people may say about OSGi is that it's complicated and messy, but nobody says that the specs are bad. Nobody says, I looked at this, I couldn't implement it, or the compliance test suite made no sense. They're well written, and it's basically because we've got this three-legged stool approach. Every single piece tests every other piece and basically forces it to be correct. Because we've got an RI, we know that the compliance tests can be passed, and we know that the spec chapter can be implemented. And because we've got a compliance test suite, we know that the spec chapter says enough detail that you can write meaningful tests based on it. So we've got all of these things validating each other, and as a result, the whole thing is strong. Also, as I say, we go through this iterative improvement process all through the RFC. And it's not just a case of we found an implementation of something and said, you know what, let's rubber stamp that. And it allows us to make really simple specs that are as simple as they can be, but no simpler. So that's what we do and how we do it. So what is it that we're doing right now? Well, RFP 176 was produced fairly early on. It was one of the first things that came into the IoT group. And it's basically talking about security in IoT, which, as I'm sure we're all aware, is a hot topic, and you can't read for more than about 5 minutes in any kind of IoT news organization without seeing that IoT security is going to be the end of IoT, or IoT security is already solved, or IoT security is the thing everyone needs to read about. It's a very, very hot topic. And fundamentally, when it comes to OSGi, it's things like, how do I know the bundle I'm installing is safe? And it turns out that we didn't need to specify anything new here, because this was a problem people realized when they were doing the first versions of OSGi. Security is baked into the core framework. So we have bundle permissions of saying what is this bundle allowed to do, and those are modular and extensible. You have code signing, so the bundle that you're installing, you can make sure it's valid and signed so that you're only taking something from somebody that you trust. But how do you cope with mistakes that people have made? And that's the big thing. It's okay to say we have security, tick, but people need to use it, and they need to use it correctly. So the RFP has actually resulted in a white paper. So the white paper is undergoing its final review. It's left the IoT at this point, and it's now going through its review in the core platform expert group, which does oversight of the other expert group activities. So it'll go through that review, and then it'll go to the board, and it should be released relatively soon. But we also have a security test suite, because we figured writing a document for people to read, whilst obviously it makes us feel good and it can go up and it'll sit there, it doesn't actually necessarily help people to do the right thing. So the security test suite is there to actually help people to do the right thing. Now, it's open source and publicly available. It is on GitHub, so you should fork it, you should try it out. It's JUnit 4, and therefore reasonably familiar, I hope, to most of you. And you can run it from Gradle, or you can run it directly in BND Tools, which is the tool that's been used to develop it. And there's also a special JUnit runner and a test probe bundle, so you can actually run tests against remote OSGi frameworks. So if what you want to do is validate the security of your gateway device that runs OSGi, you've got a bundle that you can deploy in there, and then point the tests at it, and it will run the security tests on your gateway and tell you what, if anything, it thinks might be improved. And unusually for one of these talks, I actually have an example I can show you. So you can see here we have our test. It's a pretty simple test. So what this one is doing is checking that we can't access the var log directory, because you don't want people who've written a malicious bundle to be able to exfiltrate data from your syslog, because that tends to contain stuff that you don't want just anyone to be able to see. So as you can see, it's a pretty simple test. And security tests, we aim to make them approximately this simple, because if you can't understand the test, what hope have you got of trying to pass it? And you can see here that this is pretty easy to run. We just need our run as BND OSGi test launcher, and you can see that this one is actually failing. And it's failing because I'm actually running as a user that is allowed to access my syslog directory, because I'm not, I don't hate myself. I don't want to have to type sudo every single thing I do. But what I can do is I can go into this guy. So what I can do is I can just chmod this. So I've changed the test directory in the root of my file system to be readable only by root. It's owned by root. So if I change this to be /test, and then I rerun it, you'll see it now passes. So this genuinely is validating that you've got, effectively in this case, the correct permissions set up so that the arbitrary code can't just access bits of the file system that it shouldn't. And there's more than one way to pass this test, right? So I've used operating system permissions here, but equally you could have used security permissions on the bundle to say this bundle does not have read access to the file system. Or maybe it does have read access to the file system, but only this particular folder. So however you choose to solve it, that's not down to the security test, but the security test will tell you whether this particular security hole is visible or not. So let's continue on here. So the next thing we've been talking about, RFC 229. So you can see this has already made it through the RFP process. This is an RFC now. So we're talking about implementation. And this is MQTT. So MQTT is a popular way of doing IoT information exchange. It's a broker-based lightweight communications model, and it does message queuing and topic delivery. That's kind of what MQTT does, for those of you who aren't aware. And they allow bidirectional communication, so things will either send MQTT to publish data, or you can use messages to control them. So your data feed from your sensor, series of MQTT messages published to a topic that's just there for anyone to listen. Control messages, so reconfiguring or changing the state of an actuator. For example, I don't know how many of you have seen the IoT train demo, but you've got a little arm that swings down to act as a level crossing to stop cars going across the train track when there's a train coming. That's using an MQTT message to drive the thing to say close and then open again. So the implementation that's coming in this RFC is actually heavily influenced by the experience and learning from really using MQTT to do a proper IoT project. And I know it's a demo and I know it's using Lego, but fundamentally it's still having to do a lot of the same things that a real control system would have to do. And you learn a number of things about how you want to process messages and how you want to consume this data. Smart device templates. So this is another RFP that we've got going. And basically, as I said, OSGi is popular for gateways. It's on a lot of different residential gateways. It's on a lot of different industrial gateways as well, actually. And there are so many smart devices out there. And there are ones that have existed since before IoT was called IoT. There are ones that have been created to cash in on the fact that IoT is now called IoT. And there are new ones being thought of because there are real needs for different sensors and different data collection than we've ever had before. But the problem is that all of these devices are heterogeneous, and I'm not just talking about in terms of their function, I'm talking about in terms of their actual APIs that you talk to them. No two of them are the same, and that makes it really, really hard to use them. So this RFP is gathering requirements for how we can pull together metadata to help with that situation. So HGI and 1M2M have things called smart device templates, which are an attempt to solve this problem. IoTivity have RAML definitions of various devices, and what we're trying to do is to work out how we can make best use of metadata like this to help in OSGi to make modular services for this wide variety of heterogeneous things. What we can do to help this broad array of different solutions be generally useful in a modular way. So RFP Futures, some other bits and pieces that we've got going on. Well, CoAP. So this actually came out of the same RFP as the MQTT, because it was originally just about lightweight protocols. But it turned out that we want to do potentially different things for these different protocols. So there's an RFC coming for CoAP. For those of you who don't know, CoAP is effectively a UDP version of HTTP. So HTTP is obviously done over TCP, and it's got a reliable transport. There's a connection associated with it. CoAP is very much packet-based, but it attempts to build some level of reliability over that, but not complete reliability, to be lightweight, smaller packets. It includes discovery, which isn't normally a thing you would think of in HTTP, but it's there for constrained devices. That's why it's CoAP, Constrained Application Protocol. Another thing that we found was actually relatively challenging to do and needs some help, RFID. You'll have seen we've got an awful lot of RFID readers on the OSGi train. So the trains themselves have readers, there are tags everywhere. And it's a really good mechanism for doing detection, but there are I think, 3 common standards for the RFID readers, none of which are actually interoperable in terms of API. You've got a huge variety of things that you can control and do, and actually what you really want to be able to do is to say, how do I interact with RFID readers in general without having to tie yourself to a specific frequency band, without having to tie yourself to a specific provider. What you want is you just want to be able to say, I want RFID incoming data. I don't necessarily want to have to know exactly who gave that to me or how it was delivered. So this is the really important thing. Frequency and vendor independence for this. It turns out it has been the main set of requirements coming in. We're also doing a degree of collaboration with 1M2M and potentially other standards bodies, but we have a lot of OSGi members who are also 1M2M members. And actually the OSGi core framework is part of the reference platform for 1M2M and was also for HGI, which merged with 1M2M. So there's already a fairly long-standing relationship between the two bodies, and it's about what we can do to help make sure that things that happen with as little disconnect and as little impedance mismatch as we possibly can. So that's about what we're currently doing, but you're all here, which I'm assuming means that you're interested, so why don't you get involved? So anyone can submit a requirement to an expert group. You do not have to be an OSGi member to do this. Just OSGi Public Bugzilla, you can go in there and you can add requirements. I can't guarantee that if you're the only person who wants it, that a member will pick it up, but if you've got requirements that you put in and they are in any way aligned with what a member is doing, then those things will be taken into account. Those things will end up in RFPs. You can follow the expert group's work on GitHub. So I will just show you the GitHub pages in a bit, but all RFP and RFC work is public, and it is available, that GitHub repository. It's there, it's synced automatically, so it's always up to date. Go, have a look. If you're interested, feedback to us. The thing that does require membership is if you want to actively participate in the expert group. So if you want to be part of creating a solution, you need to be a member. It's actually not that expensive to become a member if you do want to, but that's where the line is. So you can do an awful lot just by talking with us. And even the lowest level membership is enough to get people contributing to specifications. So if you're really interested and you want to do it, it's worth considering. And if you're a member, you're not just becoming a member so you're in one expert group. If you're a member of the Alliance, and you can be in all of the expert groups if you want to be. So I, for example, am co-chair of the IoT Expert Group, but I do quite a lot of work in the Enterprise Expert Group. In fact, I've been working with the Enterprise Expert Group for 7 years or more. And it's fine to be part of multiple. In fact, that cross-pollination can be really helpful. So don't just think of it as oh, I've got this one problem, maybe I should join to solve this one problem. Think of it as all of the ideas and things that are going on that you're going to get to learn about and participate in. At this point in the talk, I do need to just say that it's really important that we get feedback. So not personally for me, it's not ego, it's for all of the people who are contributing, it's for the people who are putting the program together. We want to know, what worked, what didn't work, what are you interested in, because it helps us to build better talks and better conferences in the future. So please do sign up and vote, not just for this talk, but for all the talks that you see. Now, the obligatory slide with lots of links. So this is all going to be recorded and put up, and you should feel free to go check out this information. And if you have questions, now is the time. Yes, at the back.
I have several questions regarding the IoT security. So you define test cases, right?
Yes.
You define as well the guidelines for the IoT security. So is it part of specification or
So there are guidelines in the white paper which outline a whole load of tests, and then in the GitHub repository for the security tests, which are open to everyone, I really do mean it, you should fork that repository and try it out. There's documentation as to what the test is doing, so what's the vulnerability, what is the test then testing to demonstrate that vulnerability, and ideally some suggestions of what you might do to pass the test. So for example, for the log exfiltration, make sure you've got security settings on the folders so that the user running the OSGi framework isn't able to access that directory. Or maybe the user running the OSGi framework does need to be able to access that directory, at which point you need to make sure that the bundle security is enabled sufficiently that only people who've got the bundle permission to access that directory can do it. So it's about looking at what you need your gateway to do and then setting up the security appropriately.
I have another question.
Okay.
Regarding the MQTT
Yes.
specification, which specification we want to support from MQTT, and we want to support as well the MQTT as N?
So the question is about what specifically we want to support in MQTT. So the MQTT we're looking at supporting right now is the pub sub and the point-to-point, essentially the stuff that you would think of as the basic MQTT protocol stuff. It's not more advanced than that at the moment. It potentially could be if suddenly a bunch of people came with requirements. It's still an early stage in the RFC, and we can look at whether that fits in, or at least make sure that we write the solution in such a way that extensions we know are coming will fit in nicely. But right now, not actively. The person you want to talk to is actually Tim Verbalen. He's the guy who's got the pen, so feel free to talk to him, ask him about it.
He's also around. So.
Yeah. Okay.
In industrial automation, usually devices are described by register machine. Some registers with an address and some size. And have you considered in your work about some abstraction of such devices to map particular memory layout into the parameters or something like that? Some kind of API or?
So if we had a question about you having various classes of devices with particular layouts of memory or features, so that's one of the things that will be feeding into smart device templates. It's about what are the capabilities of this device and how can they be advertised in a way that makes sense that people can rely on, because you're quite right, you get lots of different devices that maybe try to describe these things in different ways, but fundamentally you can map them to something that makes sense for most people most of the time. So that's the RFP I'd suggest that you follow.
Yeah. I mean, the smart device basically helps you to define the semantics it provides the semantics for a device, right? So we have the device abstraction here today, but it's basically empty, right? So it provides the infrastructure, but not the intelligence to integrate devices, and that's what the smart device template is actually about.
So do we have any more questions?
Might be a quick question, but with the security, control of access to directories and things, that's only within the OSGi container, is that correct?
So
no external control from the container.
So the tests are about the OSGi framework security. So it is entirely possible that the test will pass because of an external security check. So the one I demonstrated was an operating system check on the file access. But it is also possible that the problem will be solved by using a Java security manager in the framework that you set up with saying file permissions. The framework has permission to access this, but only if the bundle also has that permission. So you are correct to say that what we are checking is from the OSGi framework's perspective. What we can't tell you is, oh yes, if you install this random C program, that will also be safe. it's about the framework and the bundles you're installing.
So you can relate the OSGi security to the framework security?
So the security manager for the OSGi framework is defined in the core spec. The behavior of bundles in relation to the security manager is also defined in the core spec. You've got things like permission admin and conditional permission admin, which you can use to dynamically interact with that. And you've got a set of instructions as to how you provide a security policy for your bundle. And then it's down to governance at that point. You should only install bundles where you say, I've checked this security policy and I think it looks okay, rather than, oh, I'll install this without reading that the bundle has requested all permission. Okay, I think we've hit